Before we commence our presentation, we wish to acknowledge all of Australia's First Nations people, and in particular the Ngunnawal people on whose land this lesson takes place. Our First Nations people have been educating their children on this land for thousands of years, with this education including various elements of mathematics. Evidence of this can be found in their use of the moon, stars and planets to measure time. They're stating the number of camps between two places as an indicator of distance, and the many Indigenous artworks that include geometric shapes. We're proud to follow in the footsteps of this land's traditional owners as teachers of Australia's children. Welcome to Group 5's presentation on practice and strategies for the teaching of measurement. Group 5 comprises Zoe Fellows, James Unwin and Mike Desmond. Our presentation today will look at the scaffolding of measurement across the primary years K to 6. We'll look specifically at Year 5 measurement. We'll discuss the unit and lesson plan that specifically covers perimeter and area, and we'll provide learning activities where students will create a house in a city. We'll also briefly explore a cross-curriculum link between music and maths, and we'll discuss some of the maths, ICT and non-ICT related resources for the teaching of measurement. To fully understand the Year 5 curriculum for measurement, we feel it's important to understand the learning continuum of the teaching of measurement through Kindy to Year 6. It's more useful to explain this continuum if we separate the measurement concepts of area and length from that of the measurement of time. In Kindy, the focus is on basic length, comparing items which are longer than others. In Year 1, students start to use units of measurement such as centimetres and metres. In Year 2, students start to compare and order several shapes and objects based on length, area, volume and capacity, and using appropriate uniform units, and they use scales to compare the relevant mass of different objects. By the end of Year 3, students focus on using familiar metric units of length, mass and capacity, and in Year 4, the focus is on the use of scale instruments to measure and compare lengths, masses, capacities and temperature, as well as compare objects using familiar metric units of area and volume. In Year 5, students consider which units of measurement to use for length, area, volume and capacity, and they also start to calculate the perimeter of rectangles. Finally, in Year 6, students consider decimal representations as they relate to the metric system. They're also able to use common metric units of length, mass and capacity, as well as solve problems involving the comparison of lengths and areas. For the measurement of time, Kindy students look at the duration of events using their own language, and they connect various days of the week to events. For example, they might say that on a Sunday, we always go and visit Nana. In Year 1, students start to understand the different durations for time, including the differences between months, weeks, days and hours. In Year 2, the focus is on using languages for telling time, such as past and to the relevant hour. For example, 4:30 or 5:50. They also learn not only the names of the months, but also how to use calendars, to work out how many days each month has. This may include strategies such as the use of rhymes. For example, 30 days has September, as well as the calculation of days based on the knuckles on your hands. For example, each knuckle represents 31 days in a month, and the spaces between the knuckles represent 30 days, except for February. By the end of Year 3, students aim to tell the time to the minute and are able to investigate the relationship between units of time. For example, minutes, hours and days. This extends to Year 4, where students start to convert between units of time, as well as use the notations of AM and PM to differentiate between morning and afternoon, as well as solve simple math-based problems. In Year 5, students look at the relationship of AM and PM and convert this to 24-hour timescales. Finally, by the end of Year 6, students should be able to interpret and use simple timetables, for example, tram and bus timetables. Within this 7-year continuum, this presentation will focus specifically on the unit of measurement for Year 5. Just to recap, in Year 5, this unit includes choosing appropriate measurements of units for length, area, volume, capacity and mass, and calculating perimeter and area of rectangles using familiar metric units. I'll now pass to Zoe, who will expand more on this topic.
Thanks, Mike. The Australian Math Curriculum on Measurement, which aims are shown here, looks at real-world measurement applications which will assist students to connect ideas about measurement with what is happening in their lives and the world around them, both now and in the future. Today, we're focusing on 3 aspects of the Year 5 Achievement Standards on Measurement: the appropriate use of length and area, the calculation of perimeters, and the calculation of the area of rectangles. The learning outcomes will look at achieving the appropriate content descriptors, as seen here. The success criteria, as shown, will focus on what the students can do and know about the learning outcomes. The content is being taught with a focus on achieving the proficiency standards of understanding, fluency, problem solving, and reasoning. Understanding, where students will know what is being asked of them and can show connections between ideas. Fluency, where students understand the strategies to use in the calculation of measurement and choosing the appropriate units. Problem solving, where students use appropriate mathematical language to engage in and practice their solving skills. Reasoning, being able to use the mathematical language to explain their thinking. Using the proficiency standards means that teachers are reinforcing the significance of working mathematically. The ELPSA framework is evident in the unit and lesson design, because this lesson is aimed at building mathematical knowledge and understanding through social interaction and students' own experiences. Using the ELPSA framework allows for individual differences to be catered to as part of the lesson design. By engaging in authentic learning activities, students are more likely to become engaged with the learning, which leads to more meaningful and deep levels of understanding. Experience, students are using their prior knowledge to activate understanding and engagement. Language, the use of appropriate terminology. Pictures, for visual representation. Symbolic, the use of symbolic representation combined with real-world application. And application, multiple situations is supplied for students to learn and understand deeply. The specific terms of perimeter and area, as defined here by Akara, are examined in the lesson so that students will be able to interpret the terms correctly. This unit also includes integrated learning in the areas of science and the arts, and the content descriptors for those are shown here. I'll now pass to James for the unit and the lesson.
Thanks, Zoe. All right, so in terms of our unit, we are going to be talking about, as previously mentioned, building a house, but also building our city. But first, we're going to start off with our hook. So this video takes about 3 minutes, and I will see you all afterwards.
It's the year 2060 and you're colonizing Mars. You're about to buy a plot of land, but you have a dog and you want to make sure he has enough space to run around. You also want to build a fence so he can't escape. So first you want to know how big the backyard is, and then you want to know how far it is around. To figure this out, you have to find
the area. That's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around the shape. Just add the sides together and then you'll be great with the area. That's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around the shape. Just add the sides together and then you'll be great. Yeah, here I am on Mars, trying to find out the size of my backyard. Well, it's a rectangle, right? So what if we cut it into squares of the same size that are 1 unit long by 1 unit wide? These are called square units. Add them all up, surprise! You got 72 square units, or feet, cause that's the unit we're using. But who has time to count squares? Length times width is the quickest way to get there. Yeah, that's how you find the area. A nice little formula that'll take care of you. And I need to hurry cause my dog is starving. Let's find the area so I can feed Marvin. My yard is 9 feet long by 8 feet wide. I get the area when I multiply each side. 9 times 8 is 72. But here's another way for you to think it through. Basically, you take the rows and figure how many square units fit inside of those. Yo, my backyard is wide, 8 feet. So that's 8 rows with 9 square units in each. So multiply the 8 rows by the 9 square units, you get 72. Yup, you knew it. The area, that's That's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around a shape. Just add the sides together and then you'll be great with the area. That's the space inside. For a rectangle, its length and width are multiplied. And perimeter, the distance around a shape. Just add the sides together and then you'll be great. Now I've got my area for my yard on Mars, and there's plenty of room for Marvin to live large. But now I need a fence, cause I heard the animals on Mars could be intense. So I'll need a perimeter, the distance around my whole yard. How do you get it? Yeah, just add up the length of the sides. 9 plus 8 plus 8 plus 9's a perimeter of 34 feet. And oh yeah, that's regular units and not units squared. So let's take a look from another angle. To get the perimeter of a square or rectangle, you add 2 widths plus 2 lengths. Here's a formula, don't forget to say thanks. 2 times length plus 2 times width to get a square or rectangle's perimeter quick. So let's try it with my Martian backyard. Come on, get ready, y'all. It's not that hard. 2 times the length of 9 is 18. And 2 times the width of 8 is 16. And 16 plus 18 is 34. Now if I could stop Marvin from making a dirty floor. Come on, Marvin. Seriously.
All right, so I hope everyone enjoyed that one. It's a very catchy song, and I think it would get a lot of kids really involved in the units, particularly early on. So the unit, as previously mentioned, we're going to be doing is creating a house and our city. So students are to build a home for a family they're given, then turn it into a city by adding them to a permanent space in the classroom. This unit would take an entire term and will include integration with science and arts, as previously mentioned. Students are given details of their family, which can be easily differentiated with more difficult situations by adding more family members or pets or a pool, or by making them into pairs if the students are going to struggle with a one-on-one activity. Really, the sky's the limit with the differentiation. The house could also be as simple or as complex as you like. So to give 2 examples of that, as you can see now, the one on the left is obviously a far more simplified version of the one on the right, which is a professional house plan. But of course here, really, as I said about differentiation, the sky's the limit. And so the more the effort the students want to put in and the more detail they want to put into it, the better. As you can see, you would work out the area of your kitchen, which is so many meters by so many meters and so on. It's just completely up to the students here. They're then told the budget for the build, and they're given a specific plot of land in the area and perimeter, and they're given information on how much each room costs per square unit. For example, the bathroom would cost $100 per square unit, or the hallways might cost $60 per square unit. They will then draw out the house and add in the extra items the family has requested, while using their measurement skills to work out the cost and fit it into the space, including a fence. The great thing about such a unit is the ability to build in such massive differentiation, as previously mentioned. So to go further on that, some students who you know are going to find this task maybe too simple or too complex, you can add in even more things. So for example, the house might say, oh, they want a bath in every bathroom. And so the bathrooms have to be a certain size to accommodate the fact there's a bath in it. And then you add the cost of a bath to the sheet the student's using. Right, so then after drawing out the house, they'll be added to a wall space in the class to create city blocks, including streets. And this is where you would integrate the different unit sizes. So you're going from meters now, and you're going to kilometers, or however you wanted to do it. Next, we integrate science and arts to really build our houses. So a set of lessons would be included here to test for energy efficiency for different materials or color paint. This would include the inside as well, so if the carpet is more efficient than stone or wood floor, etc. So here you would split students up into groups of 3 or 4 students, and each of them would look at one aspect of the build. So you'd have one group who'd be your wall group, and what they would do is they'd use maybe styrofoam walls or wood walls, and they'd measure the energy efficiency of the house. And so then you're talking there about what energy efficiency is, and you're adding in that stuff from the science curriculum. But you're also still including measurement, because you're still measuring your temperature gauges overnight and your time it takes in order to actually get a real world measurement of those. So like I said, in this way, you're still implementing your measurement skills, but you're ensuring we're giving them in a meaningful way through real world problems. So all right, on to the first lesson. So the main part of this first lesson is actually to, I guess, reaffirm what the students already know about the area and perimeter from previous years, but also then to sort of include that in units that we would use for those, and then also to give them some examples. So first off, obviously you can see the area is the amount of space inside a 2D shape, and the perimeter is the total distance around the outside of the shape. We've also included units here too. So what you would do on the board is you would define what the perimeter is as such, and then you would draw a few simple shapes in order for you to work them out. So not the ones on the right, simple rectangles and squares. And then it's talking about showing efficient ways to actually work those out. So we can see quite easily that the area is the length times the width, and the perimeter we know is 2 times the length plus 2 times the width. It's obviously important here too to talk about it as length and width, not length and height or width and height. Because when we're building our house, we're going to be adding in a third dimension of the walls, and then that is going to confuse a lot of the terminology. I think it's important when you're using a 2D shape in a plane that you do talk about length and width, not height. And then it's also important to show the most efficient solution. So in terms of that as well, we have your perimeter is 2 length plus 2 height, 2 width, sorry. And so it's important to show how we actually get that. Next about efficiency is to showing them another way of how to actually separate a complex object into smaller ones. So you can see on the left-hand side, we have our complex shape. And then through one simple step of splitting it up into 2 shapes, we can show that it's actually 2 simple shapes that they could work out quite easily. And then I guess you could go through and show them that the actual area you get from both shapes is the same. All right, so next you would give them a quick worksheet just for them to cement their ideas. It's important when talking about math language that we do give the ability to actually cement their own learning, particularly if we're talking about maths as a reading language, which it can be definitely described as. If you're asking someone to read, you don't just tell them to read and then don't let them actually do it. Like you don't read to them and then say, well, you can read now. You give them the opportunity to build in their own ideas and understanding. The importance of this lesson is also as an assessment. So this lesson should be used as both diagnostic and formative assessment. So diagnostic to help you differentiate different family parameters for the main unit, so you can gain some understanding on what the students are capable of. And also formative to give students immediate feedback on any work before moving into building a house, which is going to be obviously a much more complex problem and complex unit. So next we can talk about theories and pedagogies that are used within the unit. So first off, we have problem-based learning. So problem-based learning is a teaching strategy where students are trying to solve real problems that are unfamiliar to them using their own strategies. There is significant evidence of its effectiveness. In one study, for example, groups of Year 8 students were split into problem-based learning classrooms and non-problem-based learning classrooms, and the results of the assessment were recorded after multiple lessons. Students in the PBL class performed significantly better and had far more engagement with the process. It is important to note, though, that the students in the PBL class also performed significantly worse for the first few weeks or the first few lessons. This was put down to the fact that the strategy they were using, that open-ended problem-solving strategy, was unfamiliar to the students, and they weren't coping with learning how to do that, just being dropped in the deep end. So I think if you are going to implement this strategy, you do need to take into account that this is going to take some time for the students to learn. The next one is student artwork in the classroom. So the role of permanent student artwork in the classroom has been shown to create a sense of ownership in elementary school students. It also has, interestingly enough, been shown to create a sense of belonging for the student in the school and in their community. So, and the importance of that is that a lot of evidence has been shown that if a student feels they belong to their school or community, they're far less likely to develop mental health problems throughout their adolescence and into later life, which is interesting. There's also the effects of songs on maths learning. So in a study undertaken by Song, Capraro, and Tillman, they found that by integrating educational songs and music into their math classrooms, they were able to significantly increase retention of materials in their students. Just thinking about it from your own perspective, two that come to mind immediately are the Galaxy song from Monty Python and the quadratic formula song that I learned in probably year 7 or something. And I think it says a lot that there are those songs that we do still remember from our childhood, but I guarantee you don't remember the lesson they came from. You just remember the song. So I think it speaks volumes on that fact. So now I'm going to pass back to Zoe to go through some of the extra things you can do.
Thanks, James. The following are just some additional resources that can be used to assist you in the teaching of measurement. They vary from worksheets to non-written activities to ICT-based learning, and they'll provide you with multiple modes of engagement in measurement. The Supporting Australian Mathematics Project site is an excellent resource for explicitly teaching measurement for grades 5 to 9. The Maths Worksheet Wizard will help you generate based worksheets for use in class. Sites to See is a New South Wales education resource that connects students and teachers with curriculum-aligned ICT resources for measurement. Measurement provides engaging activity-based tasks for students. Twinkle is a great resource, particularly for creating remote learning packages during lockdowns or student illnesses. Splash Learn is an interactive ICT resource which consolidates prior learning. And thank you for watching our presentation. We hope that this helped you with your future career as a teacher. And here are our references.